missed it, there was a typo in 3a. It should be x squared minus 16 in the numerator. So let's go around and let's factor things where we can. Okay, so can you factor what I'm highlighting in green? Can you factor the yellow? And can you factor the light blue? Yeah, let's go for it. X squared minus 16, the green one, should be x plus 4 times x minus 4. That's one of those world famous difference of squares. Don't write the 9 minus x yet. Let's leave that blank. We're going to come back to that. Doesn't it look weird, 9 minus x? We'll come back to that. Let's go to the yellow. Two factors of negative 90, that will produce a 1x in the middle. Any ideas? 9 and 10. So how about a plus 10 and a minus 9? That good? Gives us the negative 90 we needed, and it gives us the positive 1x in the middle. Now the blue piece, factors of 40 that add up to 14. I was thinking 8 and 5, but that would make 13x. That's no good. How about 10 and 4? Plus 10 plus 4. So everything's factored, but I left out the 9 minus x. Here's why. 9 minus x seems backwards to me. Is 9 minus x the same as x minus 9? No. I mean, put in a number for x, like 1. Is 9 minus 1 the same as 1 minus 9? No. Aren't they opposite, though? 9 minus 1 is the opposite of 1 minus 9, right? So you can actually turn 9 minus x into x minus 9 if you put a negative 1 in front of it. That's a little trick that if you have a subtraction problem that you want to flip it around, but put a negative 1 in front of it. It fixes it. Do you have to worry about that if it was 9 plus x and you wanted it to be x plus 9? You don't have to worry, just flip it. Okay? So that's why I wanted to wait on that and make it negative 1 times x minus 9. The next step in multiplying rationals is to cancel what you can. So you're looking for entire quantities that match. We're kind of like flipping little cards over and looking for things to match. You're playing a matching game. And I see a match with x plus 4, x plus 4. They're going to cancel. I see a match with x plus 10 and x plus 10. They can be in the same fraction or in opposite fractions. They'll cancel. Because when you multiply, you really just have one big fraction bar. Everybody's in the same fraction. Don't forget x minus 9 up top with x minus 9 on the bottom. So the blue cancels, the green cancels, the yellow cancels, and what's left over? An x minus 4 in the numerator and a negative 1 in the denominator. So if you want to simplify that because it looks a little unfinished, dividing x minus 4 by negative 1 is the same as multiplying x minus 4 times negative 1. If you still feel that it looks undone, think about what our little trick was up here. Instead of calling that x minus 4, multiplying by negative 1 makes it 4 minus x. That's kind of a nice, clean, final answer. So that multiplication problem, that big, ugly mess that we started with, turns out to be 4 minus x. All right? You could check your work, if you want to, by graphing this entire thing in y1 and graphing this little thing in y2 and seeing if they match. Okay? If you were asked, you might be able to find, you might have to find like holes or asymptotes, but that's really what we did back in example 2. So when you're doing these problems, you won't really be asked to find holes and asymptotes. just simplify it. And we did.